Okay, here we are with a graph of force versus displacement. So it's a non-constant force acting on an object of mass m, which is initially at rest, and we're asked to find an expression, so no numbers here, of the speed of the object. So take your time to have a go, and then when you're ready to watch on, see my answer and compare with that. Okay, so as mentioned before, there's a force displacement graph. Now, we're being asked to calculate speed, and I find that students often miss the link between these two concepts. And the link is specifically work. Now, you should be aware that the work is the product of force times distance. Now, that's only true for a constant force, and then we've got a non-constant force here, so we're going to have to work with that. Now, another thing you should be aware is that when we do work, W, we change energy. Work is a transfer of energy. And so therefore, when we do work on our object here, which is going to start moving, we are increasing its kinetic energy. And the value, the magnitude of that increase in kinetic energy is equal to the work done. Now, as I mentioned before, we have a non-constant force here. And so to get that value of the work, we're going to have to calculate the area under the graph. This is that big chunk W there that you can see on the screen. We need the area of this triangle. Well, triangles are nice and easy to deal with. I think you even may have the expression in your data booklet. Yeah, you do. Okay, we need to know half of base times height. Here the height is F1, the base is S1, and we're taking that product and halving it. That is going to be equal to our half mv squared, which is just simply the kinetic energy at the end of the process. We can now answer the question because we've got an expression with F1, S1, and m. We're going to rearrange, and we end up with a speed which is equal to the square root of F1, S1 all divided by m. And if I look there, that is my answer, B. Okay, notice there those factors of have cancelled each other out because we had a half from the energy, the kinetic energy equation, and from the area of that triangle. Now, I definitely would say this is a common question kind of territory. I've seen this expression used very often, this idea of work being the change in energy. Now, it could be a change in kinetic energy, it could be a change in potential energy, it could be work done by a force, by an object being pulled or towed by another car, or it could even be in an electric field. So it's a really, really commonly used construct. Please make sure you're aware of that link.